Hi, you have just learned about matrix properties and matrix operations in Chapter 1. You also learned how to formulate matrix equations to solve a system of linear equations. You observe that matrix operations are rather easy, but it is prone to errors. Apparently, human brain generally are not good at manipulating many numbers at the same time. Fortunately, you can use calculators to take the tedium out of matrix calculations. You can use calculators to compute the transpose of a matrix, the determinant of a matrix, the inverse of a matrix, the adjoint of a matrix, and the product of two compatible matrices. The model of calculators most commonly used by Utah Foundation students is Casio FX570MX. I'm using a compatible calculator to show you how the calculation can do most, if not all, metric calculations required by Utah Foundation course. Well, you can follow me with your own calculators. Shall we start? Let's begin. To begin with, let us key in a 3 times 3 matrix and let us call it A. Well, it contains 3 rows as is shown by the shaded row that we see, and it contains 3 columns. There is a vertical column that you see on the screen. Now let's try to key in all the 3 times 3 elements in the matrix A. Alright, let us switch on the calculators. It's on. Now first of all, you need to set your calculator to matrix mode. That's how we start. You press on the button labeled as mode. You press once. Now you observe that there are 2 modes you can set. One is it stands for computation. Now this menu or this item can be used to reset all the modes that you have previously set in your calculator. Mode number 2 is for complex number calculation, which is the topic you learn in Mathematics 1 in Foundation course. You press the second time the button mode. Right? You saw it. The first item is XD. It actually stands for standard deviation. It actually is for statistical calculation. XD being just one of the things you can calculate using your calculators. Number 2 is REG. It stands for regression analysis, which is required in your Mathematics 3 course. The third option is base, that we use to change the base of a number, like base 2, base 8, base 16, base 32, which may be useful in your programming concept course later. Let's press again. Press the button again. Mode again. You have mode 1 again. It stands EQN, stands for equations. It helps us to find the roots of up to degree 3 of 3 variables. Number 2, the max actually is just the metric calculation that we need. The third option is VCT, stands for vectors. It's used for vector calculation. We are interested in mode number 2 here. MAT stands for matrix calculation. So let us press 2. Alright, press 2. Ready? Press 2. Now you observe that on your screen there is a small label MAT indicating your calculators in matrix mode. Now let's key in our number now. The 9 numbers in the 3 times 3 matrix A. Let's start with first element 1. Alright. So let me start with your define your matrix A first. You press Shift, and you observe that above your button 4, there's MAT in yellow color. So let's choose, press 4. You have 3 options there. One stands for dimension. That means we are going to define the dimensions or the order of a matrix. Right, number 2 and 3, we leave them out at the moment. We are going to define A as a 3 times 3 matrix. There are 3 matrices we can define using your calculators. We call matrix A, matrix B, matrix C. We just use matrix A at the moment. Alright? Let's press 1, which is matrix A. It asks what is the dimension or order of your matrix. The first number stands for the number of rows, which is 3. Then we press equal sign here, which is equivalent to enter key in a computer. So equal. Then the next number n stands for the column, number of column. Again, it is 3. So let's press 3 and then equal, which is enter. Now the first number now, we are waiting for us to key in matrix A, row 1, column 1. You observe here is matrix A, row 1, column 1. By default, it is 0, but our number is 1. So let's press 1. Press 1 here. Then equal. Then the next one is matrix A, row 1, column 2, which is also 1. Enter. Next one is matrix A, row 1, column 3, which is number 2. So press 2 and then equal or enter. Next one is matrix A, row 2, column 1, which is number 4. So I press 4 and then equal. The next number is row 2, column 2, which is number 0. So I press 0. Enter. The next number is 3 for row 2, column 3. So I press 3 and then enter. Next one is row 3, column 1, which is number 5. Then enter. Right. The next number is row 3, column 2, which is a number 1. So press 1 again. So again enter. The last number is row 3, column 3, which is a number 2. So enter. Now you see when you finish keying all the nice number, the matrix display show you the very first number, row 1, column 1. You can cycle through the number to make sure you correctly key in all the elements in the matrix A. Let's try and see. Now you observe that at the button here, big button here, there is a 4 arrow key. You press the arrow key pointing to the right. 1 is to go to matrix A, row 1, column 2, which is 1, correct? Row 1, column 3 is number 2, correct? Row 2, column 1 is a value 4, correct? Row 2, column 2 is a value 0, correct? Row 2, column 3 is 3, right? Row 3, column 1 is 5, correct? And row 3, column 2 is 1. Again, it is correct. And the last number is row 3, column 3. Correct. So we have correctly entered all the numbers. So you have to give yourself a pat on your back that you have correctly entered all the values in a 3 times 3 matrix. Now let's start to do something meaningful. Let's clear the screen first. You press AC to clear your screen on your calculators, right? all the elements will disappear from our view, but it is stored in the memory of your computer. It's still there, don't worry, it's still there. Now to find out the transpose matrix, let's go to our matrix menu. So shift for matrix. This is not what I want. I want the transpose. Again, you can cycle through your menu by pressing at the navigation key pointing to the right. Red, you see the arrow key here. Let's start. I press 1. So you find 1 stands for that is a determinant. 2 TRN is a transpose. So I want the transpose. Transpose of what? Transpose of matrix A. So you must tell your calculator you are actually finding out the transpose of the matrix A that you just keyed in previously. So shift matrix, let's call a matrix A, press 3. So 1 is A. So the transpose of matrix A. You press equal sign to enter again. You can see all your elements have been rearranged as a transpose of a matrix A. Let's have a look. I press equal. So you see, math answer, the answer stands for the transpose that you have asked. It's the answer of what you have done. So it's row 1, column 1 is number 1, which is correct. You just check at the answer by the left hand side of the screen. No, you see it's 1 is there. Press again the navigation key. You see number 4 is row 1, column 2, which again is correct. Alright, then you press again, it's row 1, column 3, so number 5, again it is correct. Then row 2, column 1 is number 1, again it is correct. Press again, it's row 2, column 2 with 0, again it is correct. Row 2, column 3 is 1, no problem here. Row 3, column 1 is 2, no problem again. Row 3, column 2 is number 3, again it is correct. And lastly, the transpose of matrix A, row 3, column 3. Oh, 2. So your matrix is pretty intelligent, right? So it gives you all the elements of a transpose matrix A. But as I say, transpose matrix A is quite a simple thing to do. You may not need to resort to using your calculators. Let's do something more difficult. Right. I clear the scene again. I want now to find out the determinant of a 3 times 3 matrix. Remember, your determinant is a scalar. It's just a pure number. So let's start. I press Shift, Matrix. Alright, let's navigate to the determinant menu. Yeah, this number 1, 10 here. Alright, I press 1. Again, determinant of what? Determinant of matrix A. So let us tell our calculator is the matrix A full determinant we want to calculate. So it's shift, again, number 4, call up our matrix A, number 3, 1. So determinant of matrix A. If you press our equal or enter key now, you will see the results as 12. Bravo! We get our answer right. So the determinant of matrix A is 12. Alright. Let's find out what is the inverse of the matrix A. Now remember, in your course, finding out inverse of matrix A is quite involved and take a bit of time. But your calculator can find out for you the inverse of matrix A. Just blink of your eyes if you have keyed in the memory the matrix A. Shall we? Let me show you. It's very simple. Too simple, in fact. So I think it's better as a habit, clear the screen. Press Shift. Alright, call out the matrix. Matrix what? Matrix A, of course. It's 3, matrix A. Now to find out inverse matrix is a simple matter. You choose the symbol x to the power of negative 1. You press it, you find the matrix A to the power of negative 1. Essentially, the symbol for the inverse of matrix A. If you press the equal sign, then you can see all the elements of the inverse matrix will be shown one by one. Alright, let's try. Equal. So the first number matrix answer, they mean it's an inverse matrix, row 1, column 1. Alright, it's in decimal point, but usually we like to see in fractions. Let's press the C. It's negative 1 over 4. Compare with the answer on your left hand side, it's correct. Alright, let's go to the last element. The inverse matrix row 1, column 2. It's 0, again is correct. Row 1, column 3, 0.24. In fraction form, it is 1 over 4, correct again. So let's go to the next one. Row 2, column 1, you press again. Row 2, column 1, not that helpful, the decimal point. Change your fractions. Alright, 7 over 12. No problem there. We are quite happy so far. You press again the navigation key to the right for the next number. The matrix answer 2, 2, or the inverse matrix row 2, column 2. Alright, not very helpful the answer there. Change to fractions, negative 2 over 3. Bravo. Press again. So it's matrix answer row 2, column 3. It's, well, let's have a look. What is this in fractions? 5 over 12, correct. Again, row 3, column 1. Now this one is essentially is 1 over 3. Row 3, column 2, again is 1 over 3. The last number inverse matrix, it is row 3, column 3 of our inverse matrix is negative 1 over 3. You press again as before, you will recycle back to the very first element of our inverse matrix. Alright. It's quite simple so far. I assume you have no problem with using your calculators to find out the inverse matrix. Let's do something more complicated. Well, very often in your questions, whether in a test or in a finals, you are asked to find out the adjoint of a matrix, which is working slightly backwards. Now, the adjoint matrix cannot be found directly from your calculators, but it can be easily done if you know the formula that you learned in your class. You see, your inverse matrix is actually given by 1 over the determinant times the adjoint of the matrix A. That implies your adjoint matrix A is just your determinant times its inverse. So you can find the determinant, you can find the inverse. Finding adjoint is very simple. Let's try. Alright, again, clear the screen. I want to find out the determinant. Shift, matrix. Let's go to the determinant. Choose number 1, determinant of matrix A. Let us pick matrix A. Shift, matrix. Call out the matrix. Use number 3. A is number 1. So matrix determinant matrix A. Multiply by its inverse. So multiply by the inverse matrix. So we call out the matrix A. Shift matrix. Call out the matrix A. That is number 1. The inverse. Alright, there it is. If you press the equal sign key now, all the elements will be shown one by one again and we cycle through using the right hand side navigation arrow. Shall we start? Okay, let's press equal. Negative 3, correct. So my adjoint matrix is first element negative 3. Alright, the next one, row 1, column 2, 0, no problem. Row 1, column 3 is 3. Row 2, column 1 is 7. Row 2, column 2 is negative 8. Row 2, column 3 is 5. Row 3, column 1 is 4. Row 3, column 2 is 4 again. Row 3, column 3 is negative 4. All correct. It corresponds to the answer on the left of your screen. So, you press again, you will recycle back with the very first element of your adjoint A. Alright, as usual, let us clear the screen again for the next task. Now we want to solve the system linear equations as shown on the screen here. Alright, you have involving 3 variables, x, y, z, so you need 3 equations. As you learned in the lectures, we can transform the system linear equation into a matrix equation in the form below. Alright, now to find out the value x, y, z, or to solve the equation for the value x, y, z, you need to change your x, y, z into this form. Alright, you are multiplying by the inverse matrix on both sides to get your x, y, z as shown in your equation here. So to find out your x, y, z, essentially you need to find out the inverse of your matrix A. It's 2, 3, 3, 4, negative 1, negative 6, 4, 3, and 6. Alright, so we need to key in our matrix A now. Alright, now to change, we have already a matrix A. Let me show you how actually you can modify the content of the elements of matrix A into a new one as shown here. Alright, let's go. So I need to call out my matrix. First one, 4. Now we choose the menu edit. We are changing the value. Edit. Again, we call out matrix A. Row 1, column 1, previously is 1. Previously is 1. Now I want to change it into 2. So I press 2 equal. Row 1, column 2, the old matrix A is 1. Now it is 3. So I press 3. Then enter again. Row 1, column 3 is 2, the old one. The new matrix is 3. So I press 3 and then enter. The old element for matrix A, row 2, column 1 is 4. Right? The new one also 4. So no need to change. Just press the equal sign. Row 2, column 2 equal. Now it is negative 1. So I press negative 1. Then enter. Row 2, column 3, the old one is 3. I change to negative 6. So negative 6. Then enter again. The next one is row 3, column 1, which is 5. I change to 4. So I press 4. Enter. I change the row 3, column 2 element from 1 to 3. So I press 3. Enter. Row 3, column 3 is 2. I change to 6. So I press 6 and then enter. Alright. Let's cycle through all the numbers. 2, 3, 3, 4, negative 1, negative 6, 4, 3, 6. Alright, all correct. Let's clear the screen. Alright, so we need to find the inverse of the new matrix now. Matrix A, we have changed. We have added just now, so we can just call it out and find out the inverse. So let's go. Shift 4. I still call out the matrix A, which is number 1. Remember the inverse? We just press the x power negative 1 button on your calculator. Alright, and then we press equal sign. Alright, So this one is your row 1, column 1 of your new inverse matrix. The decimal point are not very helpful. Let's look at the infractions. It's negative 1 over 6 is correct. Alright, let's navigate to the next one. Row 1, column 2, which is 1 over 8. Row 1, column 3, which is 5 over 24. Row 2, column 1, it is 2 over 3. Row 2, column 2 is 0, correct. Row 2, column 3, it is negative 1 over 3. Row 3, column 1 is negative 2 over 9. Row 3, column 2 is negative 1 over 12. Row 3, column 3 is 7 over 36. Yes, we are done right. Alright, give yourself a pat on the shoulders. You have done well so far. Let's see how we want to find out the value of x, y, z. Essentially, just inverse the matrix A multiplied by 0, negative 1, 3. Now, in case of forgotten, your 0, negative 1, 3 consists of 3 rows, alright, and 1 column. So it is a 3 times 1 matrix. Remember, we haven't keyed in our matrix B. So we need to key in our matrix B now. Let's go. So matrix B. So you are defining a new matrix. Create a screen. Shift the matrix. We are defining a new matrix. Let's press number 1 dimension. We choose B now. Our new matrix B, which is a 3 times 1 matrix. Alright, so it consists of 3 rows and a single column, which is 1 by default. Just press equal. Alright, now let's key in the number. Row 1, column 1 in matrix B is 0, 0. Alright, enter. Row 2, column 1 is negative 1, so negative 1, enter. Row 3, column 1 is 3, so let's press 3, enter. Alright, you can cycle through and see whether it's correct or not. Let's go have a look. 1, row 1, column 1, 0. Row 2, column 1, negative 1. Row 3, column 1 is 3. Yeah, we enter all the elements correctly for matrix B. The value of the x, y, z are just essentially your inverse matrix A multiply the matrix V. We have in memory our matrix A and our matrix B. Let's call them and multiply them together. Shall we? Let's start. Shift matrix, matrix A, so press 3. 1, it's an inverse matrix, so press the button x power negative 1. Multiply by matrix B, so it's shift matrix, call the matrix B, press 3, and now I press 2, the matrix B. So now become matrix A, the inverse, multiply matrix B. If I press equal, then all the elements of your resulting matrix X, Y, Z will be known. Let's try. Press enter. First element 0.5, which is equal to 1 over 2. No problem here. You can see the next one. It's row 2, column 1 is negative 1. Again, it is correct. Press again, one more time. In fraction form, it's 2 over 3. Yes, we have get our answer for x, y, z. We have solved a system of linear equation using inverse matrix with the help of our calculators. As a good habit, just create a screen. Now that's all I will show you today, how we can use our calculator to help us to find out the transpose, the determinants, the inverse of a matrix. At the same time, how we can use the inverse matrix and another 3 times 1 matrix to solve a system of linear equations. Okay, if you have any problem, you can always contact me at the following email address. Till then, bye bye.